Hey guys, so I apologize for the blurriness of this video. I'm going to try and get it fixed for the next one. But I already have the notes filled in. I'm just going to kind of walk through them to save a little bit of time. So we are going to be talking about linear models in 1.6. A linear model uses a linear function to describe data that contains a constant rate of change, otherwise it wouldn't be linear, such as like a speed or a price or any really type of, again, rate works. And we are going to create them from either a graph, a table, or a verbal description and use our linear model to predict future values. That's the whole goal of a linear model, by the way, is to predict future values. Okay? And again, they have to have a constant rate of change that's either a speed or a price. I am changing f of x to y. Okay, they're the same thing. And this is going to be the rate or the slope times x. I guess I should add a multiplication there. So whatever your rate or slope is, you're going to multiply it by x, and then you're going to add the initial value afterwards. This is the y-intercept, and it's always where we start our graph. So that just kind of translates into where the problem starts, or the initial value of the problem is now this. So again, slope or rate times x plus the initial value. And I might occasionally write f of x instead of y. I'm just going to start introducing that so that you're familiar with it. Okay, so example 1. This graph shows Jim's distance away from home as he bikes along a straight highway. Okay, here's the graph. Perfect. So what we're going to answer is describe the relationship of this function. What that means is tell me what the variables are. And it's always going to be the y value is a function of the x value. So the y value in this case is distance from home. So his distance from home is a function of time in hours. Which makes sense because his distance from home is going to increase over time. It doesn't make as much sense to say that his time is going to increase over distance. Right? And then we're going to answer the question, how fast is Jim traveling? What does this represent in terms of this context? Well, that's his rate, which I said is the same thing as slope. So I'm going to come over here and I'm going to look at my change in y's over my change in x. And my y's are going from 128 to 161. Either subtract those, or 28 plus 30 is 58, plus 3 more is 61, so 33 is my change in y. And then I need to divide that by 3 because my x's are going up by 3. From 1 to 4 is a difference of 3. And 33 divided by 3 is 11. This basically just means he is biking at 11 miles per hour. Okay. So tell me a little bit about what that rate actually means over here. 11 miles per hour would be fine. I prefer you go back and actually look and say, oh, he's biking at 11 miles per hour, so you know whether that's something that is an accurate measure of time. If somebody were to be running at 11 miles per hour, that would be pretty impossible. So that probably wouldn't be your correct answer. Okay, now we're going to use point-slope form to convert to find the slope-intercept form. Okay, remember that for point-slope form, I need the slope and a point. I am picking this one. I could easily pick this one, but my x1 is 1 and my y1 is 128. Now, this is what we did a lot in 1.5, but it's going to be y minus the y value, 128, equals the slope, parentheses, x minus the x value, which is 1. Then I'm going to take this 11 and multiply it to the x and the negative 1. So that's 11x minus 11. And then I need to add that 28 to both sides so that y is completely by itself, giving me 11x plus 117. This right here is my initial value. This right here is my slope, as I found out up there. Okay, so when it asks us how far away from home Jim was initially, we're going to say 117 because that's what this means. It means he started 117 miles away. Okay, then it wants to know how far Jim was after 1 hour and 15 minutes. Well, that's not just in hours. We need it to be just in hours, so I'm going to take 15 minutes, and I'm going to multiply it by 1 hour over 60 minutes. Basically, this is taking 15 and dividing it by 60, because there's 60 minutes in an hour. And that is 0.25, meaning this is an hour and 0.25, or 1.25 hours. Okay, now that I know what it is in just hours, I'm going to take this and I'm going to plug it in for x right there. So 11 times 1.25 plus 117. Just like that. Then I'm going to type this into a calculator. 11 times 1.25 plus 117 is 130.75 miles. So after an hour and 15 minutes, he is 130.75 miles away from home. But keep in mind, he started at 117. Okay, so he maybe drove part of it and then started biking. Or he was already there and he's going to a friend's house or something like that. It's really far away, but there you have it. Okay, alright, example 2. I've kind of drawn some notes in here already to help you out. But it says a candle burned for 1 hour and was 6 inches tall. 1 hour, 6 inches, that's the 0.16. Then, after 3 hours, it was 5 inches tall, so we're going to make that 3, 5. And it clarifies for us afterwards, x is time in hours, that's where the 1 and the 3 come from. Y is the height of the candle, that's where the 6 and the 5 come from. Okay, first question, what is the slope of the line? Well, it went down 1 inch in 2 hours. So that would be -1 over 2. Okay, that's simple as that. The y's went down by 1, x's went up by 2, -1 over 2. Then we're going to use point slope form and convert to write the slope-intercept equation of this line. I'm going to use this point because I always just use the first point. So it's going to be y minus 6, because that's the y value, equals the slope, -1/2, parentheses x minus the x value, which is 1. Okay, and then I'm going to take this -1/2 and multiply it. -1/2 times x is -1/2 x. -1/2 times -1 is +1/2. And then I'm going to add that 6 to both sides. There you go. These cross out. 1/2 plus 6 is 6.5. Okay. Then, over here for part C, when will the candle be 1 inch tall? That means we want y to be 1, because y is our height. So, we're going to plug in 1 right here for y, which means that we have a little bit of solving to do. Okay, here's what that looks like. 1 equals -1/2 x plus 6.5. So this is the same equation I had over here, just instead of y I put a 1. And then I'm subtracting the 6.5 to the other side, and that's where I went ahead and just changed it to the decimal version. 1 minus 6.5 is -5.5 equals -1/2 x. To get rid of any fraction out front like that, multiply by the reciprocal. So instead of -1/2, -2 over 1, or just simply -2. And I'm multiplying -2 by that whole thing. That cancels these two out and leaves me with just x. And -2 times -5.5 is 11. And it's 11 hours because it asks when will the candle be, and x is in hours. Okay, I know I did not leave enough room for that one, and I apologize. I will do better in the next video. And then part D, how tall was the candle to start with? This is the y-intercept, or the initial amount, which I told you goes at the end, so it's this 6.5. Okay.